So today, the topic of our lecture is the composition of atmosphere and structure, and the very main topic is the three-layered structure of atmosphere. So before moving towards the layered structure of atmosphere, I'm gonna tell you the basic 3 to 4 lines overview of the atmosphere. So our atmosphere contains many gases, most in small amounts, including some pollutants, some greenhouse gases, and many gases in trace amounts. The most abundant gas in the atmosphere is nitrogen, and with oxygen, second, argon and inert gas, it is considered and it is the third most abundant gas in the atmosphere. So, as I have told you about that, we are going to talk about the three-layered structure of atmosphere and the composition of atmosphere. The, the question arises that why do we care about the composition of atmosphere? The composition of the atmosphere determines its ability to transmit sunlight and trap infrared light, leading to potentially long-term changes in climate. It means that our atmosphere that consists of a lot of gases, it basically determines the ability to transmit light and which leads to long-term changes in climate. So determination of climate changes is the basic purpose of the composition of atmosphere. So as I have told you that nitrogen is the most abundant gas in the atmosphere. So as you can see in this diagram in the light blue shaded area, that is the nitrogen. Out of the total 100 percentage, nitrogen is found in 78%. And then comes oxygen. Oxygen is found in 21%. Then comes the third most abundant gas, that is argon, that is found as 0.9%, and trace amounts are found in only 0.1%. But if we talk about the trace gases, that comprises of the 0.1% of the total amount. If we talk about those trace gases, we found that carbon dioxide is found in the highest amounts in the trace gases, as 93.497% is found of carbon dioxide. Then comes neon, that is found as 4.675, then helium, then methane, then nitrous, and then ozone. So from here we conclude that ozone is the gas that is found in the least amount as 0.010%. So moving towards the main topic, that is the layered structure of atmosphere. We have found about the composition of atmosphere. Now the three-layered structure of atmosphere is as atmosphere adheres earth on several bases and characteristics, as like chemical composition, then EMG, electromagnetic properties, and the third one is thermal characteristics. So atmosphere here is the main branch, and then comes the three branches: chemical, electromagnetic, and the thermal. And here lies the further branches of these three properties, as chemical comes homosphere and heterosphere, and then EMG properties has iono and non-ionosphere. And then if we come towards the thermal properties, there comes troposphere, strato, thermo, exo, and mesosphere. So firstly, moving towards the distribution of atmosphere according to chemical properties. So in chemical properties, the distribution of atmosphere is going to be discussed, and we have studied before that chemical properties have two main branches: the homosphere and the heterosphere. So first one comes towards the homosphere. Homosphere is the lower part of the atmosphere from about 80 to 100 kilometers, and there is no great variations in the composition of the gases. They are composed largely of heavier gases like of nitrogen and oxygen. That nitrogen is comprised of 79% and oxygen is 21%. So it is composed largely of heavier gases, and the wind highly mixes up the gases. So firstly, you have to remember the difference between the air and the wind, that what is the air and what is the wind. Mostly people take it as very same phenomena, but these are two different phenomena. Air is in air, molecules are still and they don't move here and there, but in case of wind, molecules move from one place to another and they mixes up. So in this chemical properties, in the case of homosphere, we talk about the wind that highly mixes up the gases like nitrogen and the oxygen, the heavier gases. In a homosphere, the wind highly mixes up the gases like nitrogen and oxygen. Then comes the homosphere contains more than 99% of the mass of the Earth's surface. More than. So it concludes that mostly the Earth's surface is comprised of homosphere, not heterosphere. Heterosphere is just a not trace amount, we can say. So let's move towards the heterosphere. So as we have discussed that homosphere is the lower part of the atmosphere, so heterosphere is the upper part of the atmosphere or the outer part of the atmosphere. Heterosphere occurs above 100 kilometers. So homosphere is between the 80 kilometers to 100 kilometers, but heterosphere is above the homosphere or above the 100 kilometers, and there is great variation in composition of gases, and it contains higher amount of lighter gases like of hydrogen and helium, and lesser winds, and thus have less mixture of gases. So in case of homosphere, we talked about that there are higher amount of heavier gases, and that's why they have heavier gases and wind mixes up the gases. But in case of heterosphere, they contain the lighter gases, so because of the lighter gases they have just less mixture of gases. So as you can see here, the heterosphere and then the homosphere. Heterosphere atmosphere is layered by molecular weight and electric charge. Homosphere composition of atmosphere is uniform. So as you can see in this diagram, the from 0 to 100 altitude, this is the homosphere, and the remaining above the 100 kilometers there lies heterosphere. So we have talked about that homosphere homosphere is the lower part and it extends from 80 to 100 kilometers, but in case of heterosphere is the upper part and it occurs above 100 kilometers. So next one is the distribution of atmosphere according to electromagnetic properties or EMG. So electromagnetic properties have for the two main types, the non-ionosphere and the other one is ionosphere. The non-ionosphere, in this non-ionosphere, the first and last and the foremost point is that it's just its height or its depth, that it lies from surface to the height of 60 kilometers above the surface of Earth. But in case of ionosphere, if we talk about, there comes many important points, like as the ionosphere is an atmospheric layer located at an altitude of about 50 kilometers and 500 kilometers, and not 50 kilometers to 500 kilometers. It is an atmospheric layer and located at an altitude of about 50 to 500 kilometers above the surface of Earth. Due to the influence of UV, ultraviolet and the X-rays from sun, air is ionized to produce large quantity of ions and free electrons. So in ionosphere, the main thing is the formation of ions, and the ions are formed when the X-rays and the UV rays fall on the surface of Earth, and due to the UV rays and these X-rays radiations, air is ionized, and that's how the ions and the free electrons are formed in a large quantity. This layer have marked effect on propagation of radio waves and thus called as ionosphere. Due to in ionosphere, radio waves are also propagated. When the UV rays and the X-rays fall on the surface of Earth, radio waves are propagated, and they cause a everlasting effect on for the formation of ions. So that's why this layer is called as ionosphere. And this is very important for communication, engineers and related studies, etc. Now, the main thing is the distribution of atmosphere according to thermal properties, because it is related to our daily activities and many more commercial activities. So thermal properties and the its main next main branches are of significant importance in this lecture. The atmosphere divided into four isothermal layers. First one is troposphere, then stratosphere, then meso, and then comes thermosphere. These all layers are characterized by uniform change of temperature. As these are the thermal properties layers, so we will discuss that in these four isothermal layers there will be a uniform change of temperature, because in these layers we will talk about the certain constant change of temperature. The top boundary of each layer is denoted by pause, where the temperature profile abruptly changes. Now, what is this pause? In this pause, we will talk about that when the one layer finishes and the other one layer starts, the boundary line of both those layers is denoted by a pause. At that pause, will be different by each layer, that when the troposphere will finish and the stratosphere will start, that boundary will be denoted as tropopause, then stratopause, then mesopause, then tropopause. So that's how these pauses will continue, will remain continue, and we will talk about more. So the first one layer, the first one layer of the atmosphere is troposphere. It mainly comprises of 80% of the atmosphere. 80% of the atmosphere is comprised by troposphere, the first layer of the atmosphere. It is the layer where life exists. It is the layer that where we live. It is the layer that sustains life. This layer starts from the surface of the earth and goes up to a height of 0 to 12 kilometers above the surface of earth. From the very surface of from the sea level, it extends up to 12 kilometers. The term troposphere literally means turnover. Like, what is the meaning of turnover? Like, it's mean that in this region air mixes and moves, resulting in a constant change. When air will move, when air will mix, there will be a certain constant temperature change. So that's how we would say that troposphere literally means turnover, where air mixes and moves. Almost when the temperature changes, when the temperature abruptly changes and there's a constant change, so that's how all type of weather exists in this layer and all type of climate changes occur in this layer. So that's why this layer is also referred as zone of weather. And then comes air is warmest at bottom layer of the earth and it gets cooled with height. Air is warmest at bottom, as you all know that at bottom air is warmest, but as we go upward, as we go towards up the mountains, as the air becomes cold, and due to which the oxygen also becomes low, oxygen level. Then when the I have told you about the pauses, so when the troposphere will end from about 12 kilometers, the boundary line between the troposphere and the next upper layer, that will be stratosphere, the boundary between them is called as tropopause. Then comes the next layer, that is stratosphere. Stratosphere, like as you can see in this diagram, that first one is troposphere, and above the troposphere there is a line that is referred at that is denoted as tropopause. So when the troposphere will end, the stratosphere will start. So that boundary line will be referred as tropopause, and that is denoted here tropopause. Then after the troposphere there comes stratosphere. Like stratosphere layer, it lies above the troposphere to a height of about 50 kilometer above the Earth's surface. So it extends from 12 kilometers to the 50 kilometers of the surface of Earth, and that's how this is the second layer after the troposphere. Temperature in lower stratosphere remains same, but beyond it there is a gradual increase in temperature. As I have told you before, that in these layers there is a constant change of temperature. So when the troposphere will end and the stratosphere will start, in the lower stratosphere the temperature will remain same, but as we go upward the temperature will change and there would be a gradual increase in temperature. So that's how you have to remember that in troposphere the temperature was decreased, but as we moved upward in the stratosphere the temperature was increased. Next one is the increase in temperature is mainly due to ozone gas forming an ozone layer. The increase in temperature is mainly due to ozone gas, and it is a variant of oxygen, and it comprises of total three atoms of oxygen. You have to know about it. And the next one is that the boundary between the stratosphere and the next layer is mesosphere. So the boundary between the stratosphere and the mesosphere is called as stratopause. As you can see in this diagram, that there is a tropopause, and after tropopause there starts stratosphere. So as the stratosphere extends till 50 kilometers, so as it is reached to the 50 kilometers, there is a boundary line between the stratosphere and the mesosphere, which is referred as stratopause. After the stratopause there comes mesosphere. Mesosphere, here you can see that after the stratopause there comes a layer that is known as mesosphere, because it is located within the 50 kilometers and 80 kilometers vicinity. 50 to 80 kilometers there is a mesosphere, and then comes the boundary line, and that is referred as mesopause. The term meso means middle, and in this layer temperature decreases with height. As I have told you that as any pause will come, as any boundary line between the two main layers will come, the temperature will abruptly change. So in the stratosphere the temperature was decreasing, but as we came to the mesosphere the temperature started to decrease with height, and it comprises of total strong winds of 3000 kilometers per hour. Like it In this layer, the winds cover the distance of 3000 kilometers per hour. And this is the last layer where oxygen and nitrogen are found. Like nitrogen and oxygen are found in abundant form, in abundant amount, but this is the last layer. Mesosphere is the last layer where the oxygen and nitrogen are found. In the next layer, that is the thermosphere, only helium and hydrogen will be found. So the last one is thermosphere. This layer lies beyond the mesosphere, and it is specifically 80 to 100 kilometers from the Earth's surface. Air in here comprises varying amount of hydrogen and helium, and temperature in thermosphere can reach up to 2000 degrees centigrade. And boundary between these thermosphere and the upper exosphere is called as thermopause. Now, last one is exosphere. The four main layers were tropo, strato, meso, and the thermosphere. But the area beyond the thermosphere is until the to the area of space. This all area is covered by exosphere. So it is the outermost layer of the Earth's atmosphere, and it marks the beginning of outer space. And the air particles here are hotter than ionosphere and many other spheres. Temperature is high because of incessant bombardment of cosmic rays, because the ultraviolet rays directly brusquely falls on the exosphere. So that's why temperature in this sphere is high, due to the incessant bombardment of cosmic rays. So I hope I have delivered it well. We'll meet in the next video. Till then, take care. Allah Hafiz.